So we said that gases exert pressure, and pressure is a prediction of kinetic molecular theory. The pressure that a gas exerts is a result of the constant collisions between the particles and between the particles and the surrounding surfaces. Gas pressure enables us to do a lot of things, drinking from straws, inflating basketballs, even breathing. Without gas pressure, we would not be able to breathe. The variations in pressure in the Earth's atmosphere are what account for the changes in the weather. Variations in pressure are what create wind, and the weather people look at the atmospheric pressure changes to help them predict what kind of weather is going to come. So the pressure is related to how many particles are in a given volume. So here we have, these look like mason jars. So here we have two different mason jars. They're the same size, the same volume. This one has more particles in it, and this one has, that one has fewer particles, this one has more particles. Yeah, it's about time to stop. So if you think about it, think about these little things bouncing around. Gas molecules remind me of the game Pong. I know that many of you are too young to appreciate how awesome Pong was when it first came out. It was like the original video game, right? And you had this little blip on the screen and a paddle at the bottom, and you could move it back and forth, and the goal was to try to just keep it going. The little blip just moved at constant speed, and it would bounce off of walls, it would bounce off your paddle, and it just kept going, right? You had to keep it from falling into the bottom. That's how I see gas molecules. They're like the Pong blip. They just go. They go, and they bounce off, and they just keep going like that. So if you think about all of these doing that, and all of these doing that, and every time they hit something, there's a little bit of pressure, right? You know, getting hit by a Mack truck is probably going to kill you. Getting pecked by a duck is not going to kill you. But have you heard the expression, I'm being pecked to death by a duck? The duck keeps pecking at you, right? It's a little peck. It's a little peck. But it gets really, really annoying, and it keeps doing it, and it's going to be a problem. It's like the fly that keeps landing on your face, right? Well, it's just a fly. Yeah, but it keeps doing it, right? So it adds up. So here we've got lots and lots of little tiny fly landing on your face, duck pecks. They add up. This is going to have higher pressure than this jar. Does that make sense? Because the particles, there's just more of them, so they're going to hit the walls more often. The pressure is going to be higher. So the pressure depends on how many particles there are. It's also going to depend on how fast those particles are moving. Because the particle moving faster will hit the wall harder, and because it's bouncing around like a crazy particle, it's going to hit a lot more frequently too. So if it's moving faster, you're going to have higher pressure than if it's moving slower. So temperature is also going to affect the pressure. Here's another application of chemistry to real life. So my family had an opportunity to go up to Lake Tahoe over Memorial Day. And so you go up in elevation, it's like over 6,000 feet up there, and as you go up, your ears pop, right? Atmospheric pressure at 6,000 feet is significantly less than at sea level, which is about where we are. So inside your ear, you have an eardrum, and that separates your outer ear from your inner ear. It's an airtight, watertight seal, so you get water in your ear, it stays out here, it doesn't go actually inside. That's a good thing. But you've got air on the inside and air on the outside. As you go up in elevation and the outside pressure becomes less, the inside pressure inside your head is the same, inside your ear. Most of your head is not empty, filled with air. It's just that little bit in your ear. The pressure builds up, and it causes your eardrum to bulge out. And the way you alleviate that is you yawn or chew gum, your ears pop, and that's your eustachian tubes that go down into your neck. Those open up, and they let the excess pressure out. And you're like, oh, I feel better now. When you come back down, the opposite happens, and the pressure builds up outside, and the inside pressure is lower, and then your ears have to pop the other way to equalize the pressure. If you've got a really bad cold and you're congested and you use eustachian tubes and everything's all swollen up, the popping is not going to go well and your ears are going to hurt. And babies have very tiny, short eustachian tubes that don't open up very well, and that's why babies tend to scream on airplanes. It's because their ears hurt really bad due to the pressure differences. And we'll stop there.